Let's talk about infinite limits. And infinite limits means that as our axis approaches a value A from the right or from the left, the y value is increasing or decreasing without bound, meaning that as I make the x value a little closer to A, the y value keeps increasing or keeps decreasing to minus infinity. And I make it a little smaller, and that y value is even bigger or even smaller. So our y values are increasing without bound to positive infinity or decreasing without bound to minus infinity when I am approaching to a value x equals A. We have seen this before. When the y value is increasing or decreasing without bound, it is because actually we have a vertical asymptote. We have learned about vertical asymptotes before when you took that pre-calculus class before coming into calculus. So every time you have a vertical asymptote, you have an infinite limit because the graph can't cross that vertical asymptote. So just imagine that you're working through a wall. There's no way you can pass through that wall, right? So what can you do? I mean, you can climb it, right? So that's kind of what the function will do. So the function, if you see the function coming from the right to the asymptote, it's going to just keep increasing without bound, but it cannot just cross over, right? The function is not allowed to do that. Same if we come from the left, again, it's going to continue increasing, increasing, increasing. We'll never touch the asymptote, but it's going to get very, very, very close to it. But again, it can cross it. So it's going to just continue increasing without bound. So when we talk about infinite limits, we just need to, like from the graph, let's just observe what is that graph doing. If I ask you, what is the limit of this function f of x, the one that we have in here, as x approaches minus 6 from the left? All right, so again, minus 6 is right there. That's our vertical asymptote, minus 6. You see the minus 6 in here. That's where the vertical asymptote is. As we are approaching from the left, this is the piece of graph that we're looking for. And that piece of graph is going towards positive infinity. Okay, when we are approaching the same number, so we are at minus 6, that's where our vertical asymptote is. But then now we are approaching that from the right. So again, this is from the right. This is the piece of graph that we want to look at. And again, that is increasing without bound, which means that this side, one side limit is also approaching infinity. Which means, again, remember that infinity is not a number, it's behavior. When we talk about limits, we're talking about behavior. We're talking about what is that value or to which value is the function approaching when I'm approaching the x to this other value. So it's the behavior of the function, what we're talking about. So when we talk about infinity, we're just saying that as the function approaches that x equals minus 6, which happens to be a vertical asymptote, both sides of the function are increasing without bound. They're both going towards infinity, which means that the limit goes towards infinity, again, because we use that definition that the limit of the function at x equals a equals L, if and only if the two one-side limits are also approaching that number. So the limit of this function as x approaches minus 6 is going to be infinity because it's approaching infinity from the left and it's approaching infinity from the right. Right, example number 2, if we have this function now, again, we have our graph, and we are going to approach 0. Okay, so again, we go back to this. So this is our x equals 0. That is the vertical asymptote that we're talking about, is the y-axis. So let's just do A first, which is the limit when x is approaching 0 from the left. So again, 0 from the left. So you need to look for that piece of graph that is getting closer to that asymptote and look at the behavior. So this is decreasing without bound, which means that the limit as x approaches 0 from the left is negative infinity. Let me write that a little better. Negative infinity. All right. What happens when we approach x equals 0 from the right? So again, this is your x equals 0. We are approaching from the right. And again, you look at the line, and this is the piece of graph that is getting closer to the asymptote. And this is increasing without bound, which means that the limit will be positive infinity. The positive, we don't write them, so you can just leave it like that. All right, so now the limit from the right and the limit from the left are heading to different directions. What does that tell us about the limit of the function when x approaches 0? Again, it's behavior, but the behavior, it's different. One is increasing without bound, the other one is decreasing without bound. So we say that for this one, the limit doesn't exist because that behavior around the vertical asymptote is not the same when we approach from the left and when we approach from the right. All right, so what happens when we need to do the same? We need to evaluate those infinite limits if we're given a table of values. Same deal, we just need to look at the behavior and we need to recognize right or left. All right, so if you need to make like a little table, we are approaching 7. So here it says we're approaching 7 from the left and from the right. So we are approaching 7. That means that 6 is in here and 8 is in here. So when you think about direction, 6.9 is right here. And that's the left. So this, it's approaching from the left, 6.9, 6.99, 6.999. So I'm approaching 7 from the left. The other side, then we have 7.1 here, and we make it smaller by adding those zeros, 7.01, 7.001, and so on. So then this in here is my right. Okay, so once you have identified that, then you know that you're going to use this for the left, and you're going to use this for the right, right? So let's see what's happening in here. So when x equals 6.9, we get 500. That's the value of the function. To find the limit, we need to observe at the pattern. And again, because it's infinite limits, we need to recognize whether this is going to positive infinity or negative infinity. So from 500, we get to this number with so many zeros, and all of those are positive, right? So the only thing we need to know from here is that this is going towards positive infinity. All right. What about the other side? What about this one? What is happening here? Kind of the same deal, right? We start with 500 and then we go down and we get to this 5 with so many zeros. And so we know that this is increasing without bound. So it's also positive infinity. So when we go here, we set the limit as x approaches 7 from the left is infinity. The limit as x approaches 7 from the right is infinity, which means that the limit as x approaches 7 is infinity because the behavior it's the same as we approach the function from both sides. All right. Next example, we have the function 4 over x minus 8. So x equals 8 is going to be our vertical asymptote. So again, recognize who's to right, who's to left. So 7.9 is to the left of 8. 8.1 is to the right of 8. And so from here, we have to talk about what is going on with that. We start at minus 40, then we go to minus 400, then we go to minus 4,000, then we go to minus 40,000, minus 400,000. So what's going on in here? This is approaching negative infinity. It's getting bigger and bigger and bigger and bigger, which means that that is going to continue increasing without bound. On the other side, we have 40, 400, 4,000, 40,000, 400,000. So what's going on in here as the x's get closer to 8? These y values are approaching positive infinity. So then from there, let's just answer to these questions. What is the limit as x approaches 8 from the left? Minus infinity. What is the limit as x approaches 8 from the right? Positive infinity. What are we going to say about the limit of the function as x approaches infinity? This is null because the one side limits are not the same. Right? So let's talk about vertical asymptotes. Okay, so we want to evaluate each of the following limits and identify if that is a vertical asymptote or not. All right, so for us, it's kind of how do we do this, right? Is the question. So we have 1 over x plus 3 to the power of 5. So we do know that we have a vertical asymptote at x equals minus 3, right? Because of the previous definition of the vertical asymptote. So what we are going to do here is we are going to see whether or not, or whether this is going to positive infinity or negative infinity. So if we need to approach minus 3 from the left, you have to think about one value that is to the left of minus 3, very close to it. So remember that we go here, this is minus 4. So then right here, we have x equals to negative negative 3.01. All right, or negative 3.1, whichever you want to use. Anyways, so if we use x equals negative 3.01, just need to use a value that is to the left of minus 3, very close to it. All right, so let's work with negative 3.01. We are going to replace that value in the x, okay? You don't need to do anything in here. If you want to put this into the calculator so that you see the value that you get, awesome, you can do that. But we can think about this mentally. So I'm going to plug in the negative 3.01 in here. So if we do negative 3.01 plus 3, we're going to get a negative 0.01 because the negative 3.01 is bigger, right? So the number that we get from this negative 3.01 plus 3 is going to be a negative number. That negative number to the power of 5, it's going to still be negative because it's an odd exponent. And then 1 over a negative number, this is going to be a negative number, all right? It's a rational function. 1 over a number that it's big. It's 1 over a number that it's small. goes towards infinity. So then this first one will be a negative infinity. All right, let me just work that out in here real quick so you see what I'm talking about. I'm gonna work out only this part with this number. All right, so we have 1 over negative 3.01 plus 3 to the power of 5. Then we have 1 over, here I have negative 0.01 to the power of 5 because that's the difference between those two numbers. If we do 0.01 to the power of 5, that is like a very, very, very small number. So it's 1 over 1 to the power of 2 times 1 times 10 to the minus 10. So then that is scientific notation is a very small number. And then if we do 1 over that, so let me just do here very small. So then this 1 over a very small, that very small number actually is negative. And when we do 1 over a negative very small number, we get a very big number. And so we get a negative infinity. All right. When we go on the other direction, so we now want to approach minus 3 from the right. So from the right, we are now here. And here we can use negative 2.9, for example. All right, so let's do exactly the same. So I'm going to change this. I'm going to change this. And so this is going to be now negative 2.9. Now negative 2.9 is smaller than 3. So then the difference here now is going to be a 0.1. And that 0.1 is going to be positive because 3 minus 2.9 is just positive 0.1. 0.1 to the power of 5 is, now here I got a real number. So this is 0.0000001. And when you do 1 over 0.00001, you get 100,000. All right. So then now our answer here, it's a positive infinity. And that is the answer here for the limit. All right, so just find a value that is very close to the x value that we're working with on the right or on the left, depending what the question is. Plug it into a calculator and see what you get. Did you get a very big number that is positive? Or do you get a very big number that is negative? That is going to give you the hint that you need to see if the infinite limit that you're working with is a negative infinity or a positive infinity. Once you have the sides, the one-side limits, then we can conclude here that the limit as x approaches minus 3 doesn't exist because the end, like that behavior near the asymptote, it's different. One is increasing and the other one is decreasing without bound, all right? But the limits are heading towards infinity, which tells you that x equals negative 3 is a vertical asymptote from the function. Where is that negative 3 coming from? That negative 3 is the value that we're using right here to find our limit. All right, so x equals minus 3 is actually a vertical asymptote because the limit for both of them are going towards infinity, as I showed you before in the graph. All right, so when we have the asymptote, because the graph cannot cross the vertical asymptote, you have that infinity or negative infinity as your results from the limits. All right, last example in here, f of x equals 1 over x plus 10 to the power of 6. So this is telling us that we are checking if x equals minus 10 is a vertical asymptote. Again, why do I know it's minus 10? Because if x is minus 10 plus 10 is a 0, and it's a 0 in the denominator, right? we cannot have zeros in the denominator. So then we're going to do the same thing. We're going to find a value that it's to the left of minus 10 and to the right of minus 10, plug it in and see what do we get. Now, you see how we have a even exponent. This means that it doesn't really matter what I have in here, if it's a positive or a negative. When I do that to the power of 6, the result in the denominator is always going to be positive, right? So then 1 over a positive is going to be a positive. So then in here, you actually don't need to do much. This is going to be positive infinity. This is going to be positive infinity. Because again, it doesn't really matter if you're using negative 10.1 or negative 9.9. The difference when you subtract that from 10, so when you do this, here we go, plus 10, this difference is negative 0.1. This difference is positive 0.1. But when you take this to the power of 6, this is positive and this is also positive. So it doesn't make a difference because the exponent is even. So both sides are heading towards positive infinity, which means that the limit exists and it's infinity. And we have a vertical asymptote at x equals minus 10. I hope this has been helpful, and please leave a comment if you have any questions about this topic.